Hello everyone and welcome to Kiru's online lectures. I am Kiraj Jamtani and today's topic is linear inequalities part 2. In part 1 we studied introduction, inequations and how to solve linear inequations in one variable. In part 2 we'll study the solutions of the system of linear inequations in one variable, and we'll also study linear inequations that involve modulus. Coming on to the solutions of system of linear inequations in one variable. So here are the rules to solve system of linear inequation in one variable. The first rule is we have to obtain system of linear inequations. Then we have to solve each inequation and we have to obtain the solution set. Then for both the equations, the solution set which we have obtained, we have to represent them on a real line. Then we have to find the intersection of the solution set which is obtained in rule 2 by taking the help of graphical representation of the solution set in rule 2. The set now that is obtained in rule 3 is basically required solution set of the given system of inequations. Coming on to the question part. So the question is solve the following system of linear inequation. Here we are provided with two inequations. So first we will solve the first equation, which is 3x minus 6 greater or equals to 0. So first of all we will shift 6 to that side. So for shifting 6, for removing 6 from this side, we will add 6 and here also we will add 6. Thus 3x is greater or equals to 6. So x is greater or equals to 2. So now we will represent this inequation in a number line. Here we have x is greater or equals to 2. So the solution set for this inequation will be 2 to infinity. Since over here equal sign is there, so this 2 is included. When we will draw number line for this 0, 1, 2, so number line will be 2 to infinity. Coming on to the second equation we have, that is 4x minus 10 is smaller or equals to 6. Adding 10 on both sides, we will get 4x is smaller or equals to 16. Thus then dividing 4 by both the sides, we will get x is smaller or equals to 4. Now x is smaller or equals to 4, that means the solution set for this will be minus infinity to 4, where 4 is included. Why included? Because here equal sign is there. Again we will draw number line for this inequation. We have 0, 1, minus 1, 1, 2, 3, 4. So this part is included here, this side, that is left hand side. Now the first inequation, first solution set of inequation was 2 to infinity, then it is 4 to minus infinity. So the intersection of these solution set is 2 to 4, as we can see they are coming on both the lines. So therefore the solution set of the given system of inequation will be 2 to 4, that is 2, 3, 4. This is the solution set of the given inequation. Coming on to next question, we have to solve this equation, which is minus 11 smaller or equals to 4x minus 3 smaller or equals to 13. So here we have two methods. We can just separate this equation. We can write minus 11 is smaller or equals to 4x minus 3 and 4x minus 3 is smaller or equals to 13. So once we will solve this part and then we will solve this part, and then we have to find the intersection of both the parts. This is one method, and other method is simultaneously we can solve both the inequations. So when we will solve this is over here in RHS side we have minus 3. So we will add 3 on both the sides. We will get minus 8 is smaller or equals to 4x. Thus, we will get over here minus 2 is smaller or equals to x. So, here we got x is greater or equals to minus 2. Similarly, over here we have to remove 3. So, we will add 3 on both the sides. So, 4x is smaller or equals to 16. Thus, here we will get x is smaller or equals to 4. So, thus when we will combine these two statements, we will get minus 2, x is greater or equals to minus 2 but less than or equals to 4. So, the solution set for this equation will be written as minus 2 comma 4. Why square bracket? Because again I will repeat, equal sign is there, these both terms are included in it. Next question is solve the system of linear inequation. So, the inequation is given 5x by 4 plus 3x by 8 greater than 39 by 8. Second linear inequation is given 2x minus 1 by 12 minus x minus 1 by 3 smaller than 3x plus 1 by 4. So, now when we will solve this first equation, we will now solve the first inequation, which is 5x by 4 plus 3x by 8 greater than 39 by 8. So, we have to take LCM over here since 8 is in the denominator part. So, we can write 10x plus 3x, which will be 13x by 8, that is greater than 39 by 8. So, thus we will get 13x is greater than 39. So, x is greater than 3. Here x belongs to 3 to infinity. Now, over here since equal sign was not there, therefore, we only applied over there the small bracket. Next system of inequation is 2x minus 1 by 2 minus x minus 1 by 3 smaller than 3x plus 1 by 4. Again we will take the bracket. So, again we will take LCM. So, on taking LCM we will get over here, this is 12, we will get 12. So, we will get 2x minus 1 minus 4x plus 4 upon 12 smaller than 3x plus 1 by 4. So, 2x minus 4x will get minus 2x plus 3 by 12 smaller than 3x plus 1 by 4. So, now shifting all the terms to here, we will get minus 2x minus 9x smaller than 3 minus 3. Thus, we will get minus 11x is smaller than 0. So, minus sign if we are shifting to other side. So, this sign will be changed. Thus, we will get x is greater than 0. So, over here x belongs to 0 to infinity. So, here it is 3 to infinity and this is 0 to infinity. So, the solution set of this particular linear inequation is intersection of both the inequations. The solution set will be 3 to infinity. So, this is how we can solve the system of linear inequations in one variable, where first we have to solve both the inequations and then whatever is the solution set of both the inequations, we have to find the intersection and that is finally the solution set of given inequations. Coming on to next topic, that is linear inequations involving modulus. Now, when we talk about the linear inequations involving modulus, so we have certain theorems over here. Like, let's suppose if in question we are provided with mod x smaller than a. So, here since we know mod is plus and minus, so here the value of x will lie between minus a, but the x will be greater than minus a but less than a. Thus, we can say x belongs to minus a to a. But similarly, if it is written like this, mod x is smaller or equals to a. So, again we will be writing x greater or equals to minus a but smaller and equals to a. Thus, here we will write square bracket to represent this equal sign. Similarly, if we have mod of x is greater than a, so this implies that x is smaller than minus a, or we can write x is greater than a. Thus, when x is smaller than minus a, that means it goes from minus a to infinity, but when x is greater than a, it goes from a to infinity. Similarly, when mod of x is greater or equals to a, so this can be written as x smaller or equals to minus a or x greater or equals to a. Now the theorem 3, which is very important theorem, that is, if mod of x minus a we are writing smaller than r, so mod of x minus a smaller than r, this implies that this can be written as a minus r. Here this implies x is greater than a minus r but smaller than a plus r, that is x belongs to a minus r comma a plus r. Similarly, if over here smaller or equals to sign is there, so a minus r smaller or equals to x smaller or equals to a plus r. But if greater sign is there, so x will be smaller than a minus r or x will be greater than a plus r. Mod of x minus r, if greater or equals to r is there, so this implies that similar to this manner we will write x will be smaller or equals to a minus r or x will be greater or equal to a plus r. So this is how these are the rules of modulus which we have to apply in our questions. Theorem 4 says a and b, if let's suppose a and b are the real numbers, so mod of x greater than a and less than b, this implies that x will be written as minus x belongs to minus a minus b union of a b. So these are certain theorems which we have to learn for applying questions which are related to modulus. Coming on to the question part, we have to solve modulus of 3x minus 2, which is smaller or equals to 1 by 2. Now we know mod of x minus a smaller or equals to r. This implies that x is greater or equals to a minus r but less than or equals to a plus r. So we will apply this theorem only over here where r is equals to 1 by 2 and a is equals to 2. So now we will solve over here. We will get 2 minus 1 by 2 smaller or equals to x. X over here is 3x, which is smaller or equals to a plus r, which is 2 plus 1 by 2. So when we will solve it, we will get 3 by 2, that is 3x is greater or equals to 3 by 2 but less than or equals to 5 by 2. Now this 3 we have to remove, so we will divide 3 by all the terms. So we will get x greater or equals to 1 by 2 but less than or equals to 5 by 6. Now over here we can see the solution set x belongs to 1 by 2 to 5 by 6. That means x is lying somewhere between 1 by 2 and 5 by 6. But over here, since equal sign is there, therefore 1 by 2 and 5 by 6 are included in it. Coming on to next question. Next question is mod of x minus 2 greater or equals to 5. Again we will apply theorem which is x minus a greater or equals to r. This theorem says x will be less than or equal to a minus r or x is greater or equals to a plus r. So the first condition we will write over here, which is mod of which is x smaller or equals to a minus r. So a is 2, 2 minus 5, so x is smaller or equals to minus 3, or x is greater or equals to 2 plus 5, or we can write x is greater than 7. So over here if we see when or sign is there, it is represented by union. So this can be written as x belongs to minus infinity to minus 3 where this 3 is included, or x belongs to 7 to infinity. So this implies that x belongs to minus infinity to minus 3 union of 7 to infinity. So the solution set of given inequation will be minus infinity to minus 3 union of 7 to infinity. So in today's video we studied how to solve the linear inequations in one variable, and also we studied linear inequations which involve modulus. Hope you guys are finding videos helpful. So do like, share and subscribe the channel. Thank you.